And remember, you can do the thing no matter what you're doing, no matter what's going on. I believe you guys can get it done. I am a little bit sorry about the late start. One second. Sorry, I made coffee and I had to go grab the coffee. Sorry so much about the late start. I was talking to my wife about emotions. We had just watched the episode on Philosophy 2 about men and abuse. And so we're talking about that. And then you get into other things. But it's fun. So, somebody followed me when I was offline. Joel McCracken, thank you so much for the follow. I appreciate you. You are appreciated. Haha! So, what happened last episode? Last episode being my last time I made 68k. And by the way, I just want to let all of you know that I was not able to export my episode 5 of my 68k programming to YouTube. Every time I did, it would say processing broke. It couldn't do it. So I was able to download the episode, but there's only audio, no video, which is uber stupid. Twitch never got back to me, and I called them a few times on Twitter, and they never got back to me. So Twitch support, fuck you. So yeah, probably next thing I'll have to do is record as well as stream. I have no idea how my computer was going to handle that, but we'll see. So there is no episode 5 on my YouTube channel, which sucks, but oh well, lesson learned. If this also will not be able to export to YouTube, that will suck as well, and the lesson will be learned. So where did we get last episode? Episode 6. I don't know. Let's find out. I haven't done this in a few weeks. Ah, yes, I now remember where we are. Where we are doing, what I am doing is addressing modes. I am making the table for addressing modes and the different kinds of addressing modes. Also, if you guys remember, maybe, I don't know. Is my dog in here? My dog is not in here. I was able to talk to somebody who has done 68k programming. And, I asked about, for example, this. And so the most significant bit has the high order, so 15, 14, 13, 12. And the op mode is written like this. So 0, 0, 0, 0, 0, 1, 0, 1, 0, that kind of stuff. So I got that figured out, which is great. But now we have the addressing modes. And now, last episode, I was starting to write the addressing modes. I was starting to understand it. Because really, different instructions have different addressing modes that they are able to use. So, oh boy, oh, that was loud. I'm sorry. So yeah, let's get started, shall we? So, addressing modes has dictionary of addressing modes. Addressing modes is a new dictionary. 4x through 8. A. Oh, what? I think I was gonna, I was making these. Right. Okay, different address. Right, so I was learning about all the, okay. Oh my god, right. All the addressing modes that I was going through and how they were gonna, I'm starting to remember this now. And I was going through the addressing modes. On top of that, I'm like, well, I have to store other data. For example, go effective addressing modes. Right, I was going through all of these and being like, how the hell do I store them? And this made sense. I could do this, and I could do that. And then we have this, and I'm like, well, how do we store the size? It's really interesting. So it's up to me to store it however I want to. Ooh, boy, I need to stop drinking that. Let's put that over here right now. A bit out of my way. So, I wasn't able to look this up, and I'm just going to do it myself. So for example, if we have EA equals AN plus size, right? Well, the size has to be stored somewhere, right? If I have an add, I would probably have add blah 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 blah, and have the indirect addressing, so I have AN, and then the size that I want to add on to it. Sorry. Well, since I'm storing this size, I have to store it in the binary somewhere, which means the assembler has to take this size and put it where it has to be. So, assembler syntax AN plus. Oh. Interesting. Actually, give me the syntax. So it is in parentheses. That's really cool. So, I have to store all of these somewhere. So we have a lot. We have assembler syntax. So we have DN. We have AN, and these are direct to the data. This is direct to the address. We have address indirect, which basically gives us the pointer to the memory that we need to get to. We have AN plus. We have minus AN, which is gonna be really interesting. Basically these two give us basically the pointer. Address reject with displacement. We have a D16, a 16-bit, AN, parenthesis. In the address register indirect with displacement mode, the operand is in memory. The sum of the address is the address register, which the effective address specifies, plus the sign extended 16-bit displacement integer in the extension word is the operand's address in memory. Displacements are always sign extended to 32 bits prior to being used. What does sign extended mean? Hey, look at that. I love it when I do programming stuff and it shows up. By the way, I know I've said this in mostly every episode, but I am looking over here because this is where my laptop is, and this is actually what's showing my chat. So if you talk to me, it's here. And I really, really, really should make a ding for that. Sign extension is the operation in computer arithmetic of increasing the number of bits of a binary number while preserving the number's sign and value. This is done by appending digits to the most significant side of the number. Following procedure depends on the particular sign number representation used. For example, if 6 bits are used to represent the number 10, and the sign extend operation increases the word length to 16, the representation will be that. Thus, both the value and the fact that the value is positive are maintained. If 10 bits are used to represent the value 15, using 2's complement, and this is sign extended to 16 bits, and the representation is that. Thus, my pattern on the left side with one is a negative sign. Okay, interesting. Okay. So, displacement always assigns to 30 bits prior to being used in effective address. Okay, so we're going to have to remember that. The emulator is going to do that. Not me, not the assembler. So basically, we can take the contents, we add it to a 16-bit integer, and then it points us to where we need to go. Cool. Oh boy. We have an 8-bit integer. We have the AN. We have xn dot size times the scale. So this addressing mode requires one extension word that contains an index register indicator and an 8-bit displacement. The index register indicates includes size and scale information. In this mode, the operand is in memory. The operand's address is the sum of the address register's contents, the sign extended displacement value in the extension word's low order 8 bits, and the index register's sign extended contents. The user must specify the address register, the displacement, and the index. So basically, take the contents, Yes, I know I'm programming. That programming guy channel. Thank you for letting me know. Alright. The only problem is if I would make a ding or something while, if I get a text, something in chat, then, I just make it so you guys don't hear it. 17 followers, man. I'm doing really good, and I just need the viewers. So we take the contents of the address register. We add to it the 8-bit integer with sign extended. And then we take the sign extended value of the index register, which is xn. We multiply it by the scale value, and we add that to the result. And we get the contents in the operand. Okay. And then we have address register indirect with index base displacement. Oh boy. So we have a base displacement, BD. We have the address register, xn dot size times the scale, scale. That should also be in here right there. It takes the address register, sign extend. Oh boy. The addressing mode requires an index register indicator and an optional 16 or 32-bit sign extended base displacement. The index register indicator includes the size and scaling information. The operand is in memory. The operand's address is the sum of the contents of the address register, the basis, blah, blah. In this mode, the address register, the index register, and the displacement are all optional. I have to remember that. The effective address is 0 if there is no specification. This mode provides a data register indirect address when there is no specific address register, and the index register's date is a data register. Fancy. This doesn't. Oh, there's the scale. Yeah, awesome. Okay. We have this. We have the base. The BD. No, already fucked it up. We have BD. AN XN dot SICE times scale OD. In this mode, both the operand and its address are in memory. The processor calculates an intermediate indirect memory address using a base address register and a base displacement. The processor accesses as a long word at this address and adds the index operand in the outer displacement to yield the effective address. Both displacements in the index register contents are sign extended to 32 bits. In the syntax for this mode, brackets enclose the values used to calculate the intermediate memory address. All 4 user-specified values are optional. Both the base and the outer displacements may be null, word, or long word. This is a lot of stuff. Cool. Memory indirect pre-index mode. Oh my god, why is there so much stuff? We take B, D, A, N, X, N dot SIZE dot 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 SCALE OD. I see. It's basically just changes when the math happens. Oh my god, coffee is... Guys, I know I say this on my gaming channel. But guys, let coffee into your life. It will change you. Okay, cool, wonderful. We have program counter indirect with displacement mode. We have D 16, a 6-bit integer, and we have the program counter. Interesting. In this mode, the operand is in memory. The address of the operand is the sum of the address and the program counter and the sign extended 16-bit. Yep. We have program counter indirect with index with 8-bit displacement. we have D8, the program counter, xn dot size bop, 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 scale. There we go. We have program counter index with a base displacement. We have the base displacement BD, the program counter PC, xn dot size scale. Cool. We have program counter memory index with post index mode. Okay. We have BD. I don't know if you can see what I'm writing. If you can't, I'm really sorry. xn dot size multiplied by the scale. I'm running out of room on my paper. This needs to stop. Program counter memory indirect pre-index mode. Okay. Oh, I said this is the same thing. BD, goddammit. PC xn dot size times scale then OD. Absolute short addressing mode. X dot dub. In this addressing mode, the operand is in memory, and the address of the operand is in the extension word. The 16-bit address is signed extended to 32 bits. So we have the extension word, and it's signed extended, and the operand pointer points to the operand. Cry. Absolute long addressing mode, which we use x dot L. Sorry. Now the question is, do we actually have .xxx, or is it a word? In this addressing mode, the operand is in memory, and the operand's address occupies the two extension words following the instruction word in memory. The first extension word. Okay. Intermediate data. Oh, immediate. Pound x. In this addressing mode, the operand is one or two extension words. The table 2.3 lists the location of the operand with the instruction word format. Okay. Effective addressing mode summary. Here we go. Wonderful. All the stuff that we can do, that we just did. Oh, hey, data memory control alterable. Sweet, so we can make this as well. That's good. So now that we have all this here, now we need to put it all in. Right? Oh boy, okay. Either I've had too much water or I've had too much coffee. I don't know which one is which is fine. Anyway, so now that we have all this and I've written it down, now I need to store all this. So how am I going to store this information? I could store it as a string, right? I could store it as a string, but here's the problem, right? Let's change the page here. In the syntax is going to be DN, so I almost have to link the syntax with the data, with the thing. However, you know, if I'm writing code, I'm not going to go D16AN. You know, I'm going to go this will be like A1, and then I'm going to have what? I don't know, 10? Something like that. It's like, well, I need to know how to do that. How am I going to know that this goes to address with displacement. And figure that out. Darren, that programming guy, did you do anything here? No, I literally did string for string for string. X is the oh, right. Yes, that was my plan. My plan was to do from 0 to... That's why I'm doing 0 to 8, because there's 8 data registers and there's 8 address registers, but that's not gonna work. That's not gonna work. Because the idea is I want to read it and then go from here. Here's the dictionary, which is what I need. But that's not going to work because that's 16 bits, 8 bits. This is going to be a lot of stuff here. So, how am I going to do this? Yeah, I can tell I've had either too much coffee or water because now my head's now I'm not thinking as much. I hate this so much. Interesting. Okay. So how am I gonna do this? Let's move this up here a little bit so you guys can see a bit more. So how am I with this? I'm going to know address with displacement, huh? Because the idea is I'm going to have data something, you know. I'm going to have for the data addressing modes, here's everything that's available. And then in it, it's going to be the data object, the address object, the indirect address object, the indirect address with post increment, the indirect address with pre-decrement is allowed. So basically, how am I gonna do that? That's really interesting. Because yeah, everything makes sense until you get to the, well, then these numbers can change. I mean, I could put this into a giant if-else statement, like, you know, okay, if the first character is a left bracket, okay, if the second character is a square bracket, okay, well, if this character is this and this character is this, you know, I could as well put it into a separate on a comma. No, that wouldn't work because, for example, if you looked at pre-index, that would get rid of the these, which is what we don't want. So that wouldn't work. So at first we'd have to be a, okay, if there is a left, there should be a right. By the way, at the moment, I'm assuming all input is correct. I'm not going to worry about error handling here. Now, fuck that shit. I'm just like, okay, do we have to find brackets? Separate those out. Oh boy, just so much stuff. So I wrote it down. I mean, I could go literally dn, we have a parenthesis, we have a minus sign, and then we can do that. So I mean, we might just have to do that first with a simple like if-else statement to figure things out and to know what addressing mode goes where. So if I'm writing this down, right, if I'm assembling this and I see that I see the address with displacement, I need to know what to write in the binary file. So I have to write down the 16-bit integer and then the address that the AN that I want. So if I write down, you know, something 10, I need to take that and I need to put in the binary thing. So let's back up here. Let's go all the way up. Let's go back to the add function, right? ADD. This can use two different kinds of address sets. Add binary, right? Addressing modes can use all of this, can use all of this. These are also good addressing modes and addressing categories is word. So add can use two different kinds of address and categories. So what page are we on? We're on page 220. Fine, add. Go to next. Da, 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 da. Haha. So add, depending on what? Depending on this, or this, we use different kinds of address and categories. So in the address and category, it needs to know what it can use. So how are we going to store this information is what I'm getting at. Oh my god. Why is my nose being stupid? Why is that? Okay. Kinds we can use. So the question is, basically in an add, I'm going to go if EA is source, use all, else use memory alterable. And then from there, in here, it's going to know what it can and can't use. Because I think the idea of what I want to get into is like, it'll go, hey, you can't use this in this mode. So I guess I'm trying to do a little bit of error detection. I won't utilize it. But I think so. I mean, right now, probably not. I mean, we don't have to really add anything. I don't have to add that error detection if I'm just trying to get it done. However, I will still need to use the logic of how to take it and separate it out. So I'll have to be able to take that and turn it into binary, which is what I need to add. So I will have to go, here's this, do this thing. So I can just have a dictionary of the syntax to the mode. I can do that. I think I might do that instead of dealing with all of this, kind of change it because I might not need it. So I can do dn, I can do an, I can do left parenthesis an, left parenthesis an plus, and then the minus. I might just have to do the tree or the try. But again, if I have this 10 a1, how am I going to take this and to get the correct mode and register? Right? That's going to be really interesting. Oh, DN and AN don't have modes. That's really interesting. So, again, so if I do add, right? If I take add, ADD, add the source, which I'm just going to say the source is DN, so I don't know, let's just say D1 space the effective address, so left, let's say I'm going to add 10 to the address, indirect address at 1, right? I'm going to have, no, this is add. Okay, let's look at the add instruction. The add instruction will be able to parse it how we need to. Okay, this is D1. We want to take data, the data at number 1, do something with it. I don't know exactly. Oh yeah, we're going to have to be able to, since we know D1 is this, we know that it's going to, we're going to have a byte, so dot B, and so like it's, you know, it's going to be 100, with the D1, and then the add blah, blah, and then this, from 10A1, we need to know that we are trying to do this. And how are we gonna try to do that? How are we gonna figure that out? Oh, how are we going to figure that out? And what does my phone want to tell me today? So somebody is texting. No. Twitch. Somebody's doing things on Twitch. That's what's happening. So I'm going to have to figure this out. But here's the thing. It could also be like this. I could also do add dot b 10a1 dn d1. I could do this as I could do it like I could do it like this as well. So I have to be able to parse this out correctly. And I think really I'm going to have to just do simple ifs and elses. I think that's what I'm going to have to do. In the simplest way possible. I know this is going to be a lot of ifs and elses. I mean, I could use regex. Oh, God. I mean, technically, what I could do is this. This is a bad idea, but I technically could do this. Are you guys ready for this? I could literally go add dot b d1, and then I could do I could literally do d16 a1 and then have the space of 10. I could do that. Then literally, then this almost. I could say A-N, and then from there I could do A1, something like that. Then literally this would then translate directly to a dictionary or a hash map so we could get what we need. I could do that. Now, there are no assemblers out there that would understand this, but it would work. And since I'm making the assembler, again, I can do whatever the hell I want. So I literally could do this, which is quite interesting. It's actually a good idea. Then I can literally just take this and go to the dictionary and go, here's what I need. But how would I know? I would really have to go, so we have the starting characters D, A, left parenthesis, and minus, and hash. From there, you would have to then go, am I using an 8-bit integer or a 16-bit integer? I would also have the... Oh, hey, look at that. The ones with brackets aren't used, so I don't have to worry about brackets. So I might just do that first. Okay, so we can start with a D. We can start with an A. We can start with a left parenthesis. And we can start with a minus. From there, we can go, oh, and we can also start with a hash. Yes. From there, we have to go, if left parenthesis, if the last one is a plus, do this. Otherwise, separate out on, comma. If it's 2, if it's this. If it's 3, it's this. Cool, wonderful. I think we got it. I think we got it. So basically, we have a Now here's gonna be the only problem. This is gonna slow down quite a lot, but because we have to go through these ifs, elses every time, it's gonna be a bit hard. Oh, I know what to do. I know what to do. I got this shit. So instead of doing this, right? Effective the address, the addressing modes. the mode is not that. Zeta 0, 0, 0. Go away. Thank you. And now this is really tiny because I monitor. Oh, I'm not going to be able to do this. Let's do that. There we go. There, now I can see everything. Okay, new effective address. Is this a string? What is this? It's a string. So I have 1, 2, 3, 4, 5, 6, 7. 1. Come on, computer. You can do this. 1, 2, 3, 4, 5, 6, 7. We have AN with 0, 0, 1. 1. We have AN 0, 1, 0. I think it's the water. We have the left AN plus, which is 0, 1, 1. We have the minus AN, which is the 0, 1, 1. We have the 1, 0, 0. 0. We have the D16 AN, like that, which is effective mode 1, 0, 1. And we have the D8 AN XN. Now if we move this over, if we move this over, and we move this over because, no, this is fine. We have more to add. We have 1, 2, 3, 4, 5. And we have the program counter as well, which we have to worry about. This is the xxx.w, which is a 1, 1, 1. We have the, yeah, I think it's the water. I think that's the water what's doing it to me. Because now I'm tired again. Man, that's what sucks about not knowing if I'm thirsty or not. I just have to guess. And if it doesn't work, well, it doesn't work. We have the, I'm off by 1. I'm missing something. D16 PC, which is, again, 1, 1, 1. And we have the D8 PC XN, which is also uno, uno, uno. So I have 1, 2, 3, 4, 1, 2. Ah, yes, I forgot hash. That's the one I forgot. Hash XXX. And this is also 1, 1, 1. Cool. So now I have that. Now that I have that, and save that. Now that's cool. So now what's going to happen is I'm going to be able to figure, why are you thingy? Oh, shut up, little bitch. Compiler, stop being a compiler. Okay, so. Okay, so now we have addressing modes. Let's also move this over so we can see what the hell is going on. There we go. So now the idea is there is going to be a translation layer between the syntax and the addressing modes. So, Oh, also I should probably do this as well. W as register 000. Let's move that over there. What did I just say again? W is zeta is zeta zeta zeta. There we go. L is zeta zeta uno. I know. Data is 100. Data is 100. D16 PC is 010. D16 PC is. Did I just say 100? Is that correct? 100, right? Oh, 010 is D16 PC. And D8 PC XN is 011. Wonderful. Okay, so now we have all that going. Thank you, by the way. So if you notice, a lot of programming is just a lot of English. I know new people, when they come to the field, they just want to code. They want to code. They want to code. They want to code. I'm like, that's fine on your own side project. However, with bigger things, it is a lot of talking in English or whatever language you're comfortable in. And so in my other series, I'm helping Asmodan learn how to code. And I keep stressing, it's like, you need to think in English first. Think in English, then translate that English to code. That's what you do. It doesn't sound as fun, but that's what you do. So this is private. Now we need to get public get adjusting mode. There we go. Return. Cool. Return null. There we go. Return null. Let's just return null with everything. All right, so there we go. So now we have to take this effective address, and we have to basically turn it into one of this. So, I could do all string comparisons with ordinal ignore case. No, lowercase effective address equals too lower. There we go. KASED. There we go. Lowercase effective address. Cool. So, first thing is, if the first letter is a D or an A, I'm going to go like this. I'm going to go, I'm going to organize these a tad bit, right? There we go. Then we have all of this. Then we get into commas. There we go. So now I kind of have it organized a tad bit. So I have things that don't start with a left parenthesis from here to here. Let's put that there. I have things that do start with the left parenthesis. Then I have things that start with the left parenthesis and are comma delimited. Yeah. Also, PC does need to be lowercase. God damn it me. How did I forget this? PC. So I'm going to lower everything. Because I don't want to keep putting string equals ordinal ignore case. That's so not fun to keep typing. So yeah. I should also add all of this to my GitHub, by the way. I keep forgetting to do that. By the way, coffee's so good. Okay, so now we have the lowercase defective address. So I can do if lowercase defective address is 0 equals D, do something. Else, if lowercase defective address 0 equals A. Also, I don't want to worry about, I guess I'm trying to optimize, but at the same time, don't premature optimize, you know? I get it. If you start with a minus, else if lowercase defective address 0 is equal to a minus, else, nope, else if lowercase defective address 0 equals a hash. So now we have everything that does not start with the parenthesis. All right, guys, are you ready for this? A comment in Python starts with a hash. I was about to use a hash to comment my code. Oh God, it's come. Okay. Test for all addressing modes that don't start with a hash. Cool. So this is just going to return. I'm just going to return null right here. 2, 3, 4. So now we have everything that starts with a parenthesis. So now we have a string array split on that. Cool. Oh, right, I need to use a character. Cool. Also, let's trim it. Let's actually trim it. Right. That's not how it works. Oh, you need characters? God damn it. There we go. Alright, so trim. Now we're trimming the parentheses off. So now we don't have to write parentheses. So now we split it up. So if... So now we have that. So basically now we split it up. So if effective addressing parts dot count, not count. No, no, I don't want to count. Damn it. Dot length is equal to 1. Do something. If addressing parts dot length is equal to 1, we're at these. So we have if just starts with A. Okay, so if we have no coffee right now, if starts with A, if effective address parts 0 equals A. And parts 0, and then so the last character is that we have something else. Can't really do anything about this. Else if I guess we could add a thing here. It's like, hey, if it's not plus, if it's something else, it's bad and we shouldn't have it. Oh shit, this won't get rid of it, will it? Oh, hey. Ooh, boy. So I don't need a trim. Dot remove. Are you serious? Replace. No, what? I did not do that. Yeah. That was the point. I want it to be empty. It can't be empty, though. Ah, fucking A, man. Dot remove, dot replace doesn't work. Dot... Where zip? No. I really don't want to do this, because this is really horrible. Like, we're already in. Like, we're already worrying about this, and I don't want to. Remove? Where's remove? Start index and count. Oh god, I can't believe I'm doing this. Remove, I need the start index. Dot remove. Oh god. Well, no. I'm gonna do this first. I'm gonna go of the right. And then I'm gonna go remove 0. This is turning out to be very bad code. I don't like this code at all. It looks really bad. But that's fine right now. I mean, once you get into string manipulation, it's all out the window. And I don't like that I'm doing this. However, hold on. I can just do a trim, right? Because, yeah, what's wrong with... I can just do a trim. And get rid of it. I think a trim is just fine. I think a trim should just be fine. Trim's just fine. This does what I need. So, however, I can't test to see if, like... if it's anything else. I can't test that, and that's the annoying thing, right? I can't really be like, well, if it's something else, it doesn't work. I could. No. I'm just going to return correct things. And then if I get to the end, I know it's incorrect. So now if the last one is W or if the last one is L. So that means if for length 1, then if effective 0. I mean, basically this is what I need right here. Cool. There we go. W. What are you complaining about? Unreachable code detected? Oh! I mean, I'm getting into the same problem where it's like, all right, well, it's A, and then we have a plus. Otherwise, just return the AN. I mean, I actually could do that, do it reversed, and I could do a test to see if there's a plus. And then go, oh, if it's AN, that'll work. How would I protect against it? How would I protect against the wrong syntax? Because it could be ANZ or AN something else, and that's incorrect. So if it's not a plus, it's wrong. So if it's equal, if the last one equals plus, that's good. I mean, technically, no. I can just do if the last one is a plus. No, if the last one is plus W or L. That's the problem, though. I see. So we get the lowercase, right? If it's 1, we have AN plus, or that. And so the problem with that is I have to test for this, or this. So if the last one is, so we have N. Wait, hold on. N won't exist. So you have to test between if, because now we're looking at this. Hold on, what am I doing wrong? Hold on. So I was able to test on characters because of this. Now I'm testing on characters because N could be an integer between 0 and 9. So I can't test on N. N will not exist in here. But these will. So I could be if the last is, if it's plus W or L, or convert it. No, I can't convert because I'm doing even more splits on that. Ugh. So I could do L, by the way, that has to be lowercase. I could do test L, test for W, test for plus, and then test the beginning. Let's do it that way. All right, so let's do it actually that way. So we're going to do it this way. Oh, God. Okay, we're going to do this, and I am not looking forward to this stuff. So basically, if you are if plus, oh, God, else if that, if you're plus, if you're W, oh boy, okay. Else if you're W and L, then else if There we go, that's what it needs. So because it's like this, I'm actually going to reverse these to kind of match how we're testing it. What did I do? Do I test for W? Oh, whoa, 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 whoa. Okay. Do I test for W or L first? Plus WL. There we go. Plus WL or AN. Cool. This is how I tested. I'm going to return all these null right now, because I don't want to deal with this. I mean, technically, it's just return, look in the dictionary. So that's cool. Return null. All right, and then we have these that I need to worry about. Where this is 2. All right, guys. It has been an hour. Everyone, thank you so very, very much for watching. What we got done today was we finally figured out how to do this thing. And the idea is we need a translating method between the syntax and the non-syntaxy stuff, so we can use the dictionary and the hash word and all that other good stuff. It's ugly, but it's gonna work right now. Is it slow? Yes. Do I give a fuck? No. Can I make it faster? Yes, but not right now. We just need to get this, make it work, basically is what we're doing. So next episode for the 68K will be in a week, Sunday at 11 a.m. For that, I'm just kind of going to continue doing this, and then I'm going to, instead of returning null, actually return what I need to return, which is great. So yeah, everyone, thank you so very much for watching. If you are watching this on YouTube, please give me a thumbs up if you like what you're seeing. If you hate what you're seeing, please give me a thumbs down and let me know why. Also, if you also like what I'm doing, also let me know why as well. I have no idea why you want to watch this in the first place. It's good to know why people want to watch this. Yeah, so lurkers who are lurking, thank you very much for lurking. Watchers who are watching, thank you also very much for watching. Bots who are botting, thank you very much for botting. Everyone, I love you, and I will see you all next week.